single node cluster. Cluster means definitely we need to have multiple nodes, but with the help of Minikube, we are only able to give single node cluster. To overcome this, we can use something called as KubeADM. KubeADM will create multiple node cluster. Then again, we are having some of the disadvantages. The main disadvantage is we are not able to create entire architecture. If you want to work on Kubernetes, you need to create entire architecture. That means combination of your nodes as well as infrastructure as well. But with the help of KubeADM, we are not able to create full infrastructure. But with the help of kops, we can definitely create the entire infrastructure. You can create VPCs, you can create buckets, you can create auto scaling groups, load balancer, everything you can create with the help of kops only. Okay. So the meaning of kops is Kubernetes operations. What is the full form of kops? Here K and O are caps and like P and S are small only. Okay. Meaning of kops is Kubernetes operations. Okay. So this container scaling as well as features I will explain later part actually. Okay, because these needs to be explained on at the last. If you want to know the problems, first of all, we need to set up the containers, right, on the cluster, and features also you will get only like when we set up the cluster. So before setting up the cluster, we need to know about this architecture. Okay. This is the simplest architecture you can understand. Okay, if you want to go for like complicated one, let me show you. Go for the here and like close this one session. Okay, type K8S architecture. Okay, go for, you will see the official architecture diagrams here. Are you able to understand this, guys? Yes, sir. You are already trained man, you can easily understand. What about you? Are you able to understand? It is very complicated, right? So first of all, I will like to take to the minimal effort. Okay, I will explain easily with the help of single egg diagram. You know egg, right? Egg diagram. I will explain like that only because, or you can simply set an onion layer. I think so. OSI 7 model will cover on your BTech days. Not no. We called someone called us like onion layer. It is like much better to understand. I will tell on onion layer. Okay. See, first of all, what you are seeing. Okay, let me explain on this way. First of all, you will have cluster. Cluster is combination of nodes. Nodes is combination of pods. Pods is combination of containers. Containers is combination of application. This is very difficult to understand. But like understand on this way by using this onion diagram. You can simply call it as, okay. What we have initially, pink. No. Top cluster. Cluster is nothing but combination of nodes is nothing but combination of pod is nothing but combination of container consists of. That's it. Okay, if I explain on normal format like others will do, it will be complicated for you. But with help of these diagrams, you will easily get what exactly the cluster means. One more time I'm saying, cluster is combination of nodes are nothing but your EC2 instances. Okay, nodes are nothing but pods. Nodes consist of pods. Pod consists of container we know. Pod is nothing but a group of containers. And inside the container, we will run our applications. That might be our monolithic or microservice. Monolithic we don't touch, but only majority of the part we will go with microservice only. So this is the basic architecture you need to understand. If you able to understand this clearly, it will be very easy for you. This is the actual infra you are going to understand, not this one. But why I have written this is, if you able to understand this architecture, it will be much easy to understand. Okay. So one more time, repeat with me. Cluster consists of nodes consist of pods consist of inside container application, like name it as microservice only because we are going to run microservice on containers. Okay. Okay. So let's go to the architecture part. This is your architecture, guys. Like if you go for the official documentation, the same architecture, but here the thing is I have written on my own. Okay, architecture I have drawn on separately. Someone is asking something. As you said, EC2 is node. Then what is pod example? So as I said, Manikanta, pod is nothing but collection of your containers. We all know containers. It is easy to host the applications. Okay. I hope it is clear for you now. Okay, so coming to the architecture part, you are only having two things. One is your master node, second one is your worker node. Worker node can be multiple worker nodes. If you want two worker nodes, you can work on two worker nodes. If you want single worker node, you can create single. Or if you want 5 worker node, you can work on 5 worker node as per your requirement. Okay, but majority of the cases, what we do is we will go with like 3+ nodes. Okay, but for practice, don't go with 3+. Practice with only one node. It is enough for you, because if you create a cluster, the IBS volume, the default is 128 GB default. It is going to cost a lot, and RAM you are going to take minimum T2 medium. Again, it is going to cost, but take one master node, one work node. It will be enough for you. If you want to update to 2, you can like create 2 nodes. Okay. So see this one. We need to concentrate more on 2 nodes. One is your master node, second one is your worker node. Master node will consist of totally 4 components, majorly 4 components. Okay, na? One is your API server, second one is etcd cluster, third one is controller manager, and fourth one is kube scheduler. Okay, so master components are this one. First one is your API server, second one is your etcd cluster, third one is your kube scheduler. Kube controller manager is different, and cloud controller manager, like this one is entirely different, guys. Okay, it like controller manager has 2 types. One is your kube controller manager, second one is your cloud controller manager. Both are controller managers, but work on different perspectives. Okay, I will tell you what are those perspectives. And coming to the node components, how many components we are having? First one is your, second one is your, third one is your. So let's go with some default like deep dive into these components. Like I have explained basic there, just components only. But let's go to the thing. First of all, let's go with like how to work on Kubernetes. We have seen architecture, right? If we want to work on the Kubernetes, we need to write a manifest file. Manifest file default format is YAML, but if you want on JSON, you can write on JSON. But the default format is YAML works on key value pair. It is also called as dictionary. Same on Ansible, on Docker, on Kubernetes. Common thing is YAML scripting language. Okay. So like if you create a manifest file and you apply to this cluster, like if you apply this, like there is a command called kubectl-f apply create, like these kind of actions we are going to perform. If you apply this manifest file, then cluster is going to create pods. If you want pods, you can create pods. If you want nodes, you can create nodes. And if you want deployment, you can also create deployment, replica, namespace, cluster IP service, whatever you want. You can create any one. Okay. But everything needs to be written on where? Manifest file only. Okay. Next, apply this cluster to bring the desired state. Pod runs on the node. As I said before, pod will always going to run on EC2 node only. Okay, which is controlled by the master. Here, this node is totally controlled by whom? Master. Okay. So let's go with the like role of the master. Here we need to observe the role of the master very carefully. Okay. The master will play a crucial role. As long as you've seen on Kubernetes, like we have seen on this one, Jenkins, we have seen, right? Master. It is the major thing we work on. And on Ansible also, we have seen Ansible server. Every action performs from where? Kubernetes, we have seen Docker Swarm. Every action performs from here also, every action will going to perform on master only. With n number of nodes you can work, but every node is going to connect to master. So if you apply something, then it is going to directly replicate to whom? Master to nodes. Okay. So let's understand what is the role of the master. Kubernetes cluster contains running containers or physical VM cloud instance all mixed. Like cluster means it is not only, for example, I have my master here. If I want to connect to my cloud node, I can connect to one cloud node as well as one physical node. It is possible, but we never do like that. But it is possible on the case of Kubernetes. Okay, it is designated one or more of this master, and all other workers are nodes. So as I said, Kubernetes master will be only one, but worker nodes can be n number of worker nodes. You can make it. Master is going to run all the set of Kubernetes process. This process will ensure smooth functionality of cluster. This is also called as control plane. So whatever the process you are doing for the Kubernetes cluster creation will be running on master only. Every process will be taken care by master only. If you run the process on master, then it is going to create nodes. Okay. So master, we can call it on Kubernetes control plane. If we call as control plane, if we call as master, okay, then the meaning is same. It is your Kubernetes master only. Next, can be multi-master for a high availability. For example, like if you are having maximum number of nodes, for example, I have a requirement like this. I need to work on 10 nodes. At that case, like only single master is not enough. If I want to create multiple master node, I can create. Same Jenkins also, we can create multiple master. If you want to work on multiple master nodes, you can work on multiple master nodes. Sorry. Appudu multiple master, like we will going to create multiple master, right? First of all, single master, I will allocate 4 nodes. Second master, I will allocate 4 nodes. Enough, right? For example, like here you are having 2 parts. I will take care of this entire part. This entire part will be taken care by like another guy. I can manage right things. Same thing is going to happen on Kubernetes as well. Clear for you? Okay. So master runs control panel to run cluster smoothly. So to run cluster smoothly, we will going to work on master only, because master is going to take care of every process for the cluster creation. But if you are working on POPs, entire infra creation will also taken care by master only. The another name of master is control plane. It is not someone will call as control panel. Okay, but the meaning it is control plane. Next, let's go to the components of control plane. Okay, so up to now we have seen the master only, meaning of like we have described about master. Let's go to the master components. What are the components we have on the master? On the master, we have something called as Kube API server. For every kind of communication, for example, if I want to run a command, only Kube API I am going to work on it. If you want to delete a pod, Kube API. If you want to create a replica set, Kube API. Node port, cluster IP, service docs, or also volumes you can create. Okay, everything you are going to work with Kube API. If a user gives command regarding kubectl or kops, it is directly going to the Kube API only. See, it is the front end of the control plane. It will directly interact with the user. That is, if we apply YAML or JSON manifest to the Kube API server, the Kube API server is directly meant to scale automatically as per the load. So, if you are having n number of loads, multiple Kube API servers, like single Kube API server only, but multiple commands are getting. At that time, it will update automatically itself. There is a possibility of scale, auto scale. We can do it. Okay. So Kube API server is nothing but if you run any command on Kubernetes, it is directly going to interact with Kube API. So here, who are going to run the commands? Users, right? If you observe this diagram, who is going to interact with the Kube API server? User, with the help of kubectl. Okay. If you are working on kops, you are going to use kops. Okay, like this. So if a user going to give a command, his command is going to get to the Kube API server only. So Kube API server is clear, right? For every kind of communication, we are using Kube API server. This part is clear. Second part is ETDC cluster. Okay, like sorry, here we need to give like the naming convention is different here. Actually, here the meaning is ETCD. Okay, I have mistaken let ETDC here. Let me correct it. ETCD. Okay. So you can simply say it as database, guys. Your cluster will consist of n number of nodes. N number of nodes will consist of n number of data to manage. All these data is going to store on some place that is called as your ETCD. Okay. You can simply call it as database to your cluster. So every data you are going to store on where? ETCD. That is only cluster data, not the whole data. Okay. Application data we are going to store it on some database service. But cluster information, cluster data is going to store on ETCD cluster only. It consists of, it is like consistent and high availability store. For example, like all the storage will be key value pair again on YAML format only. Okay. Next, source of touch for the cluster, information about the state of cluster. Okay, so it will consist of the total infrastructure, not information about the cluster. Next, you can ask me, sir, why we are using etcd only? Like we have some other alternatives, right? The meaning is it is fully replicated. So that means every cluster mode it is going to replicate automatically feature. For example, you have something like database service, like not database service, you have some cluster information. I need to make it at high available. So at that time, etcd is available form. Next one is secure. Like everything, if you want to make it encrypt, you can make it an encryption way. Okay, here that option. And third one is like you can write 1000 words per second. Like simply you can read and write values. Okay, it is almost like thousands. I have put it as 10,000, but it is thousands actually. Okay, so combining of all these together, we can make it as etcd for the better availability for our cluster. Next, third component is your kube scheduler is going to be your third component. First component is kube API server. What is the meaning of kube API server? If you want to run any command, it is going to interact with kube API. What is the meaning of etcd cluster? Cluster database only for cluster only, cluster information, not for the application. And third one is your, this is the main thing you need to focus actually, because kube scheduler is something, if you want to create the pods or if you want to manage the pods, everything will be taken care by kube scheduler. When user make a request of creation and managing pods, kube scheduler is going to take off this action on those requests, handle the pod creation and management. So that means if I'm a user, I have written manifest file. Okay, so I have written the manifest file and I have given to the kube API. API will take that and it is going to give the pod as per my requirement. But the pod is going to create it by only using kube scheduler. It will create the pods and it will manage the pods as well. If you want to edit the pod, you can edit like this. Kube scheduler match or assign any node to create and run pod. So that means if you want to, for example, if you're having multiple nodes, I have like 3 nodes. If you give the pod default, it is going to create a default node only. But if you want to create a custom node, you can create custom node like this. Next, a kube scheduler watches for newly created pods that have no node assigned. For every pod that gives scheduler discourse, it becomes responsible for finding best node for that pod to run. For example, like the meaning of this point is, if I create a pod, the pod is not assigned to the any node. The working functionality of Kubernetes is it will find the best node to match. For example, you are having 10 nodes. Okay, if you are having 10 nodes, this kube scheduler is going to find the best node for the pod. Okay, for example, if node 3 is best for this pod, it is going to directly allocate to the node 3 only. But again, if you want to customize, this, you can customize and give the required node for to deploy this pod. You have that option as well. Okay. Next, it get the information of hardware configuration from the configuration files and schedule the pods on the nodes accordingly. So again, like it will get the hardware information. Okay, like hardware configuration, like information is configurationally. Okay, so it will get the hardware configuration. It will find the best node for the pod to run. Okay, kube API will get the API commands from the user. But the pod is created actually by using kube scheduler with the help of manifest file. Clear up to now for everyone? Okay. So now go to the last component. It is called as your control manager. What is your last component? Control manager. It will make sure that actual state of the cluster matches the desired state. So that means actual state means what it is. What it is. Desired state means how we want. So it will going to match what is there and how we want. So controller manager will make sure that actual state of the cluster matches the desired state. Here again, there are 2 possible choices, guys. For example, if your Kubernetes is running on cloud, you are going to include But if your Kubernetes running on premises, bare metal servers, that means that's the difference. Like anyways, control manager is going to be same, but it differs on the provider you are going to use. If you are using any cloud provider, you are going to use Kube Control Manager. But if you are going to use a non-cloud, you are going to use, sorry, for cloud only, we are going to use Cloud Control Manager. For non-cloud provider, Kube Control Manager. Okay. See, while you are using COPS, right? If you give AWS S3 API, that means AWS will be created. If you give Azure CLI, Azure will be created. If you give GCP CLI, that means starting with GCP, GCP will be taken. That means you can include number of cloud providers. Okay. For example, like if you want to say, let me show you. You know CLI commands, right? Let me go to GCP CLI. If I directly go to this, I have some commands to run to create bucket, right? If you give directly these kind of commands, see where it is. Installing the clouds, now setting up the CLI. First of all, we need to install this CLI on the road. Okay. Like as per our understanding, we are going to work with AWS, right? So I'm going to install AWS CLI. But while you are working with GCP, right, you need to set up the GCP instance. Like if it is non-cloud, for example, like let's say it is non-cloud. Cloud means if you are going to work on AWS, you need to create EC2 instance. If you are going to work on Azure, you are going to use as Azure VM you are going to create. But if you are working with GCP, you need to create GCP like a CLI. But if it's non-bare metal, it is non-cloud provider. But if you want to include cloud provider, you need to, if you want to work on GCP, you need to install GCP CLI there. If you want to install AWS CLI, you need to go. So like this is how the things work. So this is official documentation. And if you go for here, you can easily set up the CLI for the Google GCP. And again, AWS is different. Go to the browser and type AWS CLI installation. You will find mainly 3 steps. It is like very, very easy to set up. First one is zip format. Second one is unzip command. Third one is install command. Go to the Linux. And are you seeing the 3 commands this here? If you install this one, you are going to work on AWS. But if you install this GCP, you are going to work on GCP, Google Kubernetes Service. Clear for everyone? That's it. Okay. So next one. So components on the master that run controllers. For example, like here, let's say about the controller. We have n number of controllers, guys. Okay. If you observe here, you have only control manager, but inside the control manager, you have some n number of controllers. First one is your node controller. What is your first one? For checking the cloud provider to determine if a node has been detected in the cloud after it stop responding. For example, I have a node. If it stop responding, then node controller is going to like work on this. Then we are using cloud controller manager, right? Yeah. So at that time, you will have some other service. These are some other service, right? We will work on this. We have some other service alternate for it. Okay. But like how the thing is, if a pod is automatically stopped, it is going to recreate. Actually, we need not to find detect it. Because on real time, how we'll set up is auto scaling will directly set up. If I have 10 pods, for example, if I have 10 pods, I don't let it 10 pods. Okay. I will create some auto scaling for it. So that means if a pod will go down, immediately other pod will come. So that means here, this is, if you use this, you have no problem. If you also don't use this, we will work on the directly. It is like possible on the Kubernetes. What is the second controller? So for setting up networks and route means like the traffic from where to where you are going to route the traffic. Okay. For to setting up this network and route, you are having route controller. Third one is your service. This is something related to load balancer. Like remember, if something you hold it on Kubernetes on Docker, it is called as service. Load balancing is definitely going to involve on it. Because if you want to work on a service, definitely load balancing is going to work there. Without working load balancing, we are not going to work on service on real time, on practice as well. Okay. Service controller. For load balancer on your cloud against services of type load balancer and volume controller. Like if you want to create, we have seen volumes, right? If you want to work with like volumes, this controller manager will have something called as volume controller. Will create the volume, attach the volume, and multiply the volumes as per your requirement. So these are some of the things you have inside your controller. Again, first one is your, second one is your, third one is your, and fourth one is volume controller. Okay. So like these are the major components of your control plane. First of all, Kube API server. Like I will tell it on like single line for your better understanding. So see this one. API server is to expose API. So that means commands will directly go to the API server. Commands will be given by whom? User. In which format? ML, called as manifest. And etcd cluster consists of data. Kube scheduler will do everything that is creating a new pod, controlling a new pod. Yes, pod related activities will be taken care by Kube scheduler. And controller manager, we are having two things. If you are working on cloud controller manager will talk to the cloud provider. But if you are working on bare metal, you are having Kube controller manager. So these are the major components of your master component. You can call it as control plane. So let's go to something about your node components. If you observe here on node components, how many components you are having? Mainly 3 components only. First one is kubelet. So kubelet is nothing but one of the agent running on the node. Okay, we have n number of nodes. If you observe on like this one Jenkins, you have agent there. Ansible, you have agent there. Likewise here also we are going to run an agent here. Okay, it listen to the Kubernetes master. So this main functionality of the kubelet is, if you observe this diagram, is it listening to master or not? So remember, this kube proxy, kubelet, and container engine all will be associating to master only. That to Kube API server. Next one. The default port number is 10255. Kubelet. Okay, but if you want to change it, you can change. Like you can change on the manifest file. Next. For example, if a pod is there, okay, if a pod is there, if it is running successfully or failurely, this kubelet is going to generate a report to the master. Next, container engine. We know like majority of the real time we are using 99.99% Docker only. If not, we are using CRIO. You know CRIO, right? Like a lot of people will know about CRIO. It is also same like Docker. And something called as your Rocket. Okay, Rocket engine. All these are your container components. You can create containers by using Docker, CRIO, or Rancher as per your requirement. Next, it can be your Docker, Rocket, or any other. So container engine will work with the kubelet only. Okay, because kubelet is the agent that is going to work with the pods on the node component. Next, the main use is like to get the images and to work with the containers. And even we can also expose to the port numbers by using this container engine. Like simply we can say it as Docker, guys. You know Docker, right? So this container is nothing but your Docker only. Next, last one is your Q proxy. Assign IP to the each pod. So proxy means listen. Proxy means listen. It will assign the IP to the each pod. Next, it will require the IP address to the pod. So the thing is, proxy means, remember, wherever you are going to work on proxy, it is contained. It is entirely on your networking only. You can assign your IP addresses. You can assign your DNS names and any other thing. So something that is related to your network is going to be working on with Q proxy only. Next, it run on each node. It will make sure that each pod will get unique IP address. So, and one more thing Q proxy will do is, each node we will have Q proxy. Each node we are having a number of containers and pods. Okay, so for each node we are going to give a unique IP address. If you give the same IP address to the same nodes, like multiple nodes, is it going to work for us? It won't work, right? Because like for the different nodes, we can't able to give the same IP address. Next, All these three components, kubelet, kubeproxy, and container engine is collectively called as node. Okay, all these are called as collectively node because node will consist of all three components like this. So one more time I'm saying that. Let's go with architecture. What is a cluster? What is a node? What is the pod? What is a container? Application. We can make it on the pod. Okay, so one more thing, like cluster is done. We have seen the cluster. Cluster components is done. Node components is done. Container we all know, right? We have seen a lot of things about container. And application as well as microservice also I have explained to you. How to create application like 1 tier, 2 tier, 3 tier on the starting of our class. And what is microservice? The only thing we left here is pod. So pod we need to discuss about now. Let's go for the pod discussion. So this is what you call as your pod. Pod is the smallest unit of Kubernetes. If you want to talk about Kubernetes, the smallest unit in Kubernetes is pod. It is group of one or more containers that are deployed together on the same host. So as I said before, pod is nothing but combination of different containers. You can create 3 to 4 containers and you can make it on a single pod. You can declare the, like you can deploy the entire pod. So that means 3 to 4 containers will be deployed on the same pod. Next, a cluster is a group of nodes. This we all know. A cluster has at least one master node and one worker node. This is also like we have done. In Kubernetes, control unit, it is the pod, not container. So if you observe, in Kubernetes, main thing is not containers. Main thing is only pod. Because inside pod only we are running containers, right? The main functionality of the Kubernetes is to orchestrate containers. But where these containers are lying? Inside the pod. So that means the main component in the Kubernetes is pod only. Okay. Next. Consistent one or more tightly coupled containers. So that means it will contain like one or more than one container. But on real time, we will go with only one pod, like inside a single pod, we are going to maintain single container because on future, if you want to scale up, you can use the same pod. Okay, but multi-container pod we can create, but it is not recommended. I will show you like how to create single container pod as well as how to create multi-container pod. Next, pod runs on the node, which is controlled by master. So where we are going to run the pods? Inside the nodes only. Node is controlled by master, as we all know. Next, Kubernetes only knows about pod. It does not have any individual container. So that means Kubernetes will never know what inside the container is. Kubernetes will only occupy for pod. Again, I am saying Docker will know everything about container, but Kubernetes doesn't know about container. Kubernetes mainly depend on pod only. Inside the pod, we can contain our containers. Cannot start container without a pod. If you want to like start a container, for example, like I have my multi-service application on the Kubernetes cluster, but I don't have any pod. Only containers are there. I'm not able to work on Kubernetes. If you want to work on Kubernetes, main thing you want is pod. Inside the pod, you are going to get inside the container the applications, as we all know. One pod usually only consists of one container. As I said, real time also, you are going to maintain single pod. Sorry, single container or single pod. But again, if you want to create multi-container pod, you can create. It is happen, but we mostly work on single pod, single container. Let's understand something about your multi-container pods. Okay. Share access to the memory space as well as connect to each other using localhost. If you want to connect to your localhost, I have 2 containers. You can connect by using localhost. Like without also having without IP, just to give sh-localhost, it will be connected. There is a possibility. Share access to the same volume. Like if I create 2 containers inside the same pod, volumes can be shared inside the same pod only. But if I have 2 pods, one pod volume is not going to share to the another pod. It is not possible. But if you are having volume inside one container for like one pod, it can be shared to the same volume, like same container inside the same pod. It is possible. Next, container within the pods are deployed in all or nothing manner. So that means if I have a pod, I cannot deploy single container. If the pod consists of 3 to 4 containers, I need to deploy the whole containers. Okay. But if I want to deploy a single container inside a single pod, which is totally 4 pods, it is not possible. Okay. If you are deploy a pod, that means if you are having 10 containers, these 10 containers need to be deployed at the same time. Okay. But you are not able to do one among 10 containers on the pod. Next. Entire pod is hosted on same node. So that means like single pod is going to host on single node only. You cannot host multiple. Okay. Each pod you are going to host on each worker node. That means. And we are also having some limitations for it. Okay. By default, no auto scaling and no like what we call the auto load balancing will be there. No auto scaling and no auto load balancing. LB I'm saying like LB means load balancing. This is the main disadvantages. Auto scaling we need to do it manually, but Docker Swarm we can do it automation. Load balancing we need to do it on manually here Kubernetes, but there automation we can do. Next, if a pod crashes, solution for that is high level K8s object, but we need to add this. If you pod it, like if there is a pod, if the pod crashes, we can create automatically another pod. We have that like what we call the advantage. Okay, but the limitation is we need to go for higher level K8s object. So that means we need to touch these kind of components. Okay, yeah, the same one. So if a pod crashes, I create a single pod. If I want to recreate it, you need to know something about higher level K8s objects. That is called as your replica set, deployment, and what is called a server volume, service and volumes. Okay. Replica set. Simply we can see Docker replicas, right? The same here as well. You can create automation, number of copies you want. Okay. Second one is deployment. So that means you can roll back. Like these components will be understandable when you are in this component. Like when I create the first pod, you will get understanding about all these components. I will explain that. Okay, don't worry. Third one is your service. An application single feature is called as your service. And fourth one is your volume. We all know. Use it for storage purpose. These are what you call as your higher level Kubernetes objects. What we call it as higher level K8s objects. And here, like something we need to know about these important notations. Okay. If you are work on the single node or single kite, we are going to use kubectl. But if you are using on premises, you are going to use. If you are working with kubefed, that means you are federate like hybrid code. But this is not important because on cloud or else like bare metal, we can use kubectl as per our requirement. Okay. So these are the some theoretical concept on Kubernetes only. I'm not going to start any of the practical session today because to start the practical session, you need to have at least this cluster information. Because if you don't have cluster information properly, if you set up cluster, that will be hell for you. Okay. So for today only, this is day one of Kubernetes. I will only talk about the theoretical concept. But from tomorrow, I will go to the cluster setup, pod creation, as well as like cluster IP, node port service, replica set, daemon, namespace, all things I will cover one by one. Okay. So one more thing I'm going to explain all the concepts. So Kubernetes is mainly to manage the containers. It is nothing but your orchestration service to manage the containers. Okay. So alternate for Kubernetes is Docker Swarm, which we have seen on last class. So coming to the like Kubernetes, it can be supported by any type of cloud provider, as well as you can use it on physical machines, virtual machines, and cloud machines. Okay. Comes to the history, originally it was given by the Google. Named it as Brog, but later they named it as Omega. But on 2014, they have open sourced it by using a name called Kubernetes. Okay. And like this is completely written on Go language and later given to CNCF, means Cloud Native Computing Foundation. So if you want to platform, like if you want to practice on online, you will have Kubernetes Playground, play with Kubernetes, and Kubernetes Classroom. But if you want to use on cloud service, GKS, Google Kubernetes Service, AKS, Azure Kubernetes Service, and coming to AWS, EKS, Elastic Kubernetes Service. Okay, like tools we need to use is Minikube, Kubedium, and Kops. And remember, all these things are not required. For single node, Minikube. For multi-node with total infrastructure, Kops. This container scale-up problems and feature like you are going to discuss after this Kubernetes is done. Okay, but I have like given here, ignore this one. And like comparison also, Docker Swarm we know, but Kubernetes we don't know, right? So comparison part, all I will going to explain on the last class of Kubernetes. So coming to the cluster is combination of node is combination of pod is combination of container consists of applications. So this is the Kubernetes architecture. Here we are having two. First one is your master, second one is your master, also called as control plane. How many components there will be on master? And on like node? 3. Total 7 components. 4 on master and 3 on node. Okay. So the main component is API. API, for example, if a user gives the command is taken care by the API server. EDCD cluster contains of total in cluster data. And after that, kube controller. Kube scheduler. Yeah, scheduling the pod, creating the pod, managing the pod. Everything pod related activity will going to taken care by scheduler. And controller, we have two controllers. One is kube controller, second one is cloud controller. If you are using cloud provider, cloud controller manager is going to talk with the cloud provider. But if you are using bare metal server, non-cloud, then you are going to use kube controller manager. And coming to the node components, kube proxy is nothing but your network, like everything related to networking. IP address, DNS, all things will be taken care by the kube proxy. Next, kubelet. Like if the agent is running or not, it is going to store the information like that. And container engine, we are known, Docker, Rocket. The thing which create the container is called as your container engine. But on majority of the cases, 99.999%, everything will be on Docker only. Okay. Next one. So this thing we have also seen. And what is the pod? Smallest unit in Kubernetes. The pod will consist of containers. Can we deploy one container if we have 10 containers on the single pod? No, we need to deploy entire pod. By default, how many containers you can create on a single pod? 1. If you want to scale up, you can scale up by using auto scaling concept. Okay. Multi-containers pod also same. But instead of single container, you have multiple containers. If you want to share the volume, one pod to one pod volume is not shared. But on one pod, multiple containers volume can be shared. This is what you call as your multi-container pods. And what are the higher level KATS objects? Replica set, deployment, service, and volume. Okay, and some important notation like this is not required. So these are the basic things we have covered on Kubernetes. From tomorrow, we are going to start the Kubernetes cluster creation. Okay, so for the online people, are you having any doubts here? Yeah, definitely, Raghavendra, I'll share. Like, actually, I'm not feeling well from the couple of days. So once I recover, I'll share you. Don't worry. So like people, like guys, are you good for today's class or having any doubts? Good. Okay. Okay. Is this Kubernetes any difficult for you guys? Like as per my understanding, for a fresher, it is very difficult. But what I'm expecting is you are not expecting that much of difficulty from the Kubernetes. Am I correct?